Well, this is the Skutter neck version 1, about to give the test run. That's all aluminium. I've got a bungee cord, and that's at about 2.5 kilograms tension. The original prop had a bungee cord, but no idea what tension that was set at. Now we've got a 1.1 kilogram weight at the end of the neck. I'm guessing the head that I'm printing up now is going to be about 300-400 grams with the servos and all that in it. So if it can lift this, I should be safe lifting the head. We've got a linear actuator doing the driving. So it's one of these. It's 12 volts. It's either 21 millimeters or 30 millimeters. I haven't decided yet. And it's 188 newtons, which I think is about 18 kilograms of force. When I had this set up without the actuator, doing a full test with this scales, I was getting about 12 or 14 kilograms of force initially to get it moving. So fingers crossed, it's not going to blow the actuator out. Here we go. Okay, so it's the arm going up and the arm going down, or the neck going down. Hopefully you can see that. Well, that's 11.9 volts. So I'll get that raising. So it's about 190 milliamps. So that's not too bad. One thing that's a bit of a downfall with these actuators, it won't hold mid position. So I've got the power off it now. Oh, it is going to hold mid position. Okay. I've been trying it out and it wasn't holding mid position before, so I don't know. Oh, yeah, there you go. It's slowly moving. I think that's a goer. I can now put that actuator inside the square tube to hide it and continue on with the neck joint and the hinge and that's underneath the hard hat section of the Skutter. Skutter neck test number 2. So we've got the fingers opening and closing and the head tilt. The head up and down, I'm waiting on servos to roll up. And that's the neck joint with the actuator in it. Closer view of the finger mechanism. I'm waiting for some smaller ball links to roll up. These are just a little bit too big. Close-up view of the head tilt, and you can see the hinge here for the head up and down. Closer view of the elbow or the neck joint. with the weight of the head and that on it, there'll be a bungee cord to add a bit of spring loading on it to help everything out, just like the original. Skutter neck test number 3. So I've got the 3D printed fingers on the Skutter now. So they open and close okay. I've also got the neck tilt, or the head tilt, and up and down. Of course everything works still while the neck's going up and down. Version 2 of the 3D printed fingers have been removed. So we can see the Ball Race Metal Gear Heavy Duty Servo. This is 20 kilograms. Because the new fingers are a lot thinner, they're 0.6, where the old version was 1.4 mil wall. Takes a lot less force to open and close the fingers, so this could be a 10 kilogram servo. Then we have a standard hobby servo here, RC servo for the head tilt. I couldn't use a heavy duty servo here because it had to be small enough to fit inside the square tube. Then at the back we have the head raise and lower servo. So this is a heavy duty Metal Gear servo. The neck joint here is using the same 188 Newton DC actuator as I've previously been using. The rubber boot, this one, I just went to the local auto shop and rummaged through their stock until I got one about the right size. So I could have 3D printed one, but the fingers took a day and a half to print because flexible filament you got to print slow, and that was like 20 millimeters a second. So it was just as easy to go to the auto shop and get a pre-made boot. That was like $18, a lot less mucking around. Quick update on my Skutter build. So the base is done. We've got the drive system in with the speed controllers. That black box is the battery. I think it's 12 volt, 12 amp hour. More than likely to be drive it for quite a few hours. And so we've got the rotate section in, and the arm, I've got the head off it at the moment. Talk about the head. There's the head with the servo connections. On top of this piece, the dome will sit. We'll just swap this out in a minute, show you the progress on the main body. So we've got the electronics here, so we've got a motor driver, Arduino, couple voltage regulators, MOSFET relay to open and close the eye, or to do, to turn the eye on and off, and got the radio control receiver with a 16 channel S bus adapter. This receiver is what I've just been testing it with, but doesn't have enough channels. It's only 8 channels. This is the underside of the base plate. We have casters on the back and the scooter wheels at the front for the drive. So this is the Skutter body. I'm still in the priming stage, so it's only grey undercoat. So the underside is we've had the printing the panels in sections and then glue them together. Because this is ASA, being able to weld the panels together with acetone, so that makes for a pretty strong joint. I have put some fasteners in there just to hold it together while it's drying. So it's got some Greeblies that go on the side, and that arrow goes on the other side with a couple 6mm lengths of acrylic. So this is the Skutter body on the base plate and with the dome or the helmet section on. I don't have the head on it at the moment. The dome attachment needs a little bit more fat one around to make it sit a little bit level. But there will be a 4 or 5mm gap between the bottom of the dome and the body. A couple more Greeblies to go on the back flat bit there. Alright, thank you for watching.